I want to welcome you. I'm Kelly DeLong. I'm the Executive Director for the Kentucky Center for Mathematics. And this afternoon, we're going to talk about contextualizing proportional reasoning. You can always email me. I'm there at this email address. And that smile on my face is because I may have one of the best jobs in America, and that is working for KCM has been a treasure for me. But those of you who've known me for a long time know that I love math education. The Kentucky Center for Mathematics is housed out of Northern Kentucky University, but really what we are is we're a professional learning group of educators, and our job is to spread the wonderfulness that is math education. And I think you're here with us because you know exactly what we mean by that. We all are here because we love math education. Our website is found at kentuckymathematics.org. And again, as I was saying earlier, it houses all of our materials, and you'll be glad to have those. They're there for you at any time. So as I was starting to think about this session, my goal was to say, all right, so how can I help middle school teachers really think about sending worthwhile tasks to their students? And one of the themes that we really are talking about here at KCM is this idea that less is more, and that why don't we now take advantage of the opportunity to have a rich task and allow students to be able to think about that. So our goal today is to contextualize proportional reasoning. I'm going to press on your thinking with regards to proportional reasoning and get some strategies. Think about what some of the strategies are, more than just cross, multiply, and divide out. That is so limiting for students. There's a lot of rich ways for kids to think about that. I'm bringing you a technology integration tool, and then we're actually going to do a little math that you can actually taste, and I've got some setup here for us to do that. So let's start with this. So look around. I'd love for you to get out a sheet of paper and a pencil. So see if you've got that, because you may want to be able to have that at your disposal. Okay, fantastic, fantastic. We are going to do three math problems, thinking about them quickly. I'm watching my time very closely, and going to show you a math simulation. We always start with some research, because the thing about mathematics that's so important is to realize that this research has been around for a while, and to really think about things. And so the first one, I bring you and I say to you that I propose that proportional reasoning may be one of the most important math skills in adult life. Just absolutely 100%, one of the most important math skills in adult life. And so we see that it has all kinds of diverse topics with regards to that. So then I go here, okay? I'd love for you to read what's in green. The strategies, again, that students are apt to use when approaching a task are, as well as the likelihood of the student's success or failure at solving it, are influenced by that task content in the numerical structure. So one of the things that we're really going to think about as a subtext of what we're doing is this idea of why are the numbers what they are, and thinking about that with mathematics, because one of the articles that I used that I think that is so important is this article right here. I'm going to, let me minimize my screen. I actually want to show you the article. In your handout, you'll have access to this article called Saving Money Using Proportional Reasoning. It's by researcher Jessica De La Cruz. And this article, out of course, our mathematics teaching in the middle school. You guys know that these are articles that we adore. And Jessica really had some great ideas about contextualizing our mathematics. So thinking about that the math that we have kids do needs to be in context. So I'm going to go back to the screen, and I'm going to ask you to start solving your very first math problem. I'll be looking for the answers in the chat. So I'm going to ask you to do this. Paper towels. 8 rolls of Bounty for $8.99. 6 roles for $7.99. My question to you is, which one is a better buy? If you'll go ahead and put that in the chat box. Kind of put what you're thinking about in the chat box. One thing that I'd love is, Dee, if you could help me by narrating some of those ideas in the chat box. That'll help me to multitask.
Will do.
Dee's my sidekick. All righty. What do we see rolling in those chat boxes, Dee? I'm going to unmute you.
I thought I was unmuted. So some folks went to the unit rate, and so we've got $1.12 per roll for the first one, and the second one is $1.33 per roll. So, and then some folks have just put in that the 8 rolls is the better buy. People were also writing some things in about the number of sheets or square feet, like maybe there's some more information.
Yeah, I see that. Lisa says, I look for the number of sheets or square feet to determine the value. So hilarious that that she thinks about it in that way. So as you're thinking about it, wondering that you solved it one way, is there anybody who is able to solve it 2 ways? This is where I'd love for you to unmute and tell me about the 2 different ways that you thought about it.
So I found a common multiple between the 8 rolls and the 6 rolls. So that would be 48. So I found the price for each of them if there were 48 rolls. And
Beautiful.
I don't see the 8 rolls is still cheaper.
What about that? Beautiful. So double checking your answer. Bobby, was that your first way you thought about it?
Just trying to deal with, trying to think about it as a 6th grader.
Yeah.
I do RTI math, and so this unit came like right after some of the fraction background stuff. So I was trying to think about approaching it one way that they would.
Fantastic. So Bobby gives a great example. So this is really kind of the crux of what I want to talk to us about today, and that is that we should take away this cross multiply and divide out thing that tends to be pervasive in math education. We do it too soon. And so in the article by Dela Cruz, she says, look, we do this too soon. So think about the methods that are available for students. And I propose that the multiple entry points could be all of these. So the first is a buildup or a reduction. So did you all hear that Bobby did that? She actually was thinking about it in terms of 48. So she kept making sets of it until she got to a point where that all had the same amount. So thinking about where that number lies and realizing their number sense. Another thing is, depending upon the numbers, we could do a factor change. So one could be twice as big, one could be half as much. And so that in the 2 numbers, you could manipulate one or the other. I propose that Bobby could be seeing this ratio as the common denominator was 48 rolls. And so maybe she was thinking about that way, but I tend to think that she was doing a buildup, which is why we have to be almost mathematical sleuths with regards to what is it that the kids are doing and how are they thinking about it. And then the one thing that we will say is unit rate is very powerful. Unit rate is very powerful, so that kids thinking about it per one. But what was it about these numbers that kept us from thinking about unit rate, or made unit rate a little more messy? Can somebody unmute and kind of say that? Maybe what was it about the numbers that made unit rate maybe a little more messy?
I think the money just didn't break down beautifully.
That's exactly right.
Split into those like nice, perfect little $1.50 or something like that. It was a little bit messier in terms of division.
And so what happens, Maggie, is we go back to what Dela Cruz was telling us in the research, and she said, you know what, if you use numbers like that, because those are numbers in the grocery store, that then kids can do one of two things. We think about it in terms of powerful math where you're rounding, but even when you rounded, the numbers weren't so pretty. So you're right, you're exactly right, Maggie. So I propose to you that part of our proportional thinking and contextualizing is this idea of a better buy. So the things that I'm bringing to you today are to have those discussions with middle school teachers, that now is the time to ask kids questions with regards to this real world math. They are going to the grocery store with their parents. They could linger for a moment in the paper towel aisle, tell them which one is ask them which one is the better buy, justify their thinking, and then, you know, drop them off in that aisle and say which one's a better buy and why is that? And having them think about this idea of using some of these skills that we have. What happens if I do this? What happens if I add a third option, which is what's going to happen when the kids are in the grocery store with their parents, if they've gone to Kroger, if they've gone to Food Lion. These are popular grocery stores with the folks that are out there. Well, what are you thinking about now? Which is the better buy? Carrie says, look, I'm still saying that 8 rolls is a better buy. That's right, it didn't change. Cindy says that 2 for $3 happens to be $1.50 each. Now, we are shoppers, right? We actually know this. We know it is the precipitous by why people go to Costco and for some items. So thinking about buying in a bigger bulk may actually give us some savings. But the audience for these kinds of questions happen to be our students that are 11 and 12 years old. They don't have the experiences like you and I have. I would love for you to give middle school students these sorts of questions in order for them to be able to answer. This is some of the best math that we could be doing at this time. So thinking about this again, I'm going to come back to these multiple entry points. With a proportion, we want to be asking kids questions that allow them to build up or reduce the mathematics. We are looking for kids to have that same idea with regards to factor change, right? Thinking about it. At 1 o'clock, we had a high school session with Leah, who's here with us this afternoon. And she was talking to us about scale, of course, at the high school version. And this is the beginning of that thinking about multiplying up, finding this common denominator. What does it look like? And thinking about unit rate. So we think that shopping math, so the first thing is, I believe that the math of shopping is one of those power things that we can be doing right now with our middle school kids. So in the article, I loved the very clear view of how Dela Cruz says, all right, so look at what we can think about. So at unit rate, we can think about it per 1 row. We can also think about, all right, so what if everyone had 2 rows? So what beautiful mathematics about thinking about the fact that what if it is a reduction problem and you're thinking about, so what is that by 2 roles? And again, this kind of setup and this kind of mathematics really makes sense to kids because they've been doing some equivalent fraction work. This extends that thinking in regards to equivalent fraction work. And then take a look at common denominators, right? I'm going to call this the Bobby methods because she was thinking about it in terms of 48 roles. And then we could do 24, all right? Thinking about it in that way. So that problem is very powerful. So now I want to go to one that has been kind of cornerstone in my teaching career when I even know how long it was ago, probably longer than some of you were alive, but I used a program called Connected Mathematics, and they had a question in there called what is the orangiest? This is a version of that happens to be open source. Again, here at KCM, we're always cognizant of our copyright. And so this is an open source question. You can find it located at I call it the Shell Center, which is actually the Math Shell Center. It is also referenced as Mars Resources, but it has, if you look at my handout, there are 23 pages that how we can take this one question and extend it the entire week as we're giving these to our middle school kids. Now, so always one to want to have something that makes it fun. So what I want to show you is that I have a little setup here for the math. So excuse me while I'm going to get out of sharing my screen. And then I'm going to make sure that you guys can see my setup. So there it is. Okay. So I've got the orangey question. And the question is this, and I'm asking it to you. I'm going to ponder. I'm going to say it out loud. And then I'm going to ask that you enter into the chat which one you think is the orangiest, and I'm going to be making it in the background, okay? So I'm bartending. This is Kelly's virtual happy hour, and I'm bartending for you. And so the question is, this is asking 3 parts orange to 4 parts soda, and I'm using Fresca, one of my favorite drinks, had it in my refrigerator. And the other drink is going to have 4 parts orange and 5 parts Fresca. So you guys ponder that while I'm mixing, while I'm doing the mix. All right, beautiful. Got a little fizzy orange juice going here. Gonna come back to video. Take a look at the chat. Yes, Cindy Aussie, this is exactly my favorite part of it. She says, you know what, Kelly, you might even be able to taste the math. So I'm gonna do a little sip. Delicious. So I wonder about what's the orangiest. So I'm looking for your answers and what you're thinking about that in regards to that in our chat box. So I'm watching them come in. I'll be drinking 3 to 4, one more sip of that. Has a certain flavor. I can taste the Fresca. Oh, you know what's so funny is I thought that the math wasn't going to be far enough apart for me to make a difference. I'm telling you, I can taste a difference. I'm telling you, I'm not lying. You can actually taste the difference. Who would like to unmute and talk to me a little bit about your thinking? Is 3 to 4 orangier, or is the 4 to 5 orangier?
Don't be bashful.
I've got good wait time. Don't I, Dee? I've got good wait.
Yeah, none of us bite. Lots in the chat box, but people aren't unmuting. Yeah.
Yes, I see. Beautiful. So indeed, you're thinking about it. If I'm, Julie, help me to know if I'm understanding it. She's thinking about it as 4/5. So thinking it about 4 parts orange to 5 parts soda, and saying that it has to be a little more stronger. Maggie says that that's 75% to 80%. So the 4/5 happens to be orangier. So I wonder, what I love about the activity is that I had it thinking with regards to the 3 to 4 and did not do part to whole. So we know that one of the natural things that we do with students is we automatically go part to whole, and we just say part to whole, part to whole, part to whole, and then turn it into a decimal and turn it into a percent. Well, I say to you, it's that relationship. It's contextualizing the math, right? So we're talking about the fact that you can actually taste it. Like I can tell you I can taste it. And you should do this at home. It can be 3 parts of anything and 1 part of something else. Notice also that the question itself actually talked about liters. That's ridiculous. We can't go and mix, 7 liters worth of juice for something. So I just used a teaspoon. Because what you really need to know is that that has to be the same. It's the very same proportional concentration. It's the same taste on my tongue. I love that. So I'm going to go back to sharing my screen again. Thank you for all of those answers. Look at those great math that's coming in. Dee, will you narrate that for me while I'm getting back to my slide? What do we see there that some of the, I saw?
Sure. So in that's a card sort that comes as part of this math shell. And kids are asked to sort of sort those cards to put those proportions and those ratios together. So they've got words and then visuals of what it actually looks like, parts of orange to whatever your fizzy soda is.
And so one of the things that we love at KCM is indeed a card sort. So imagine that the students would be able to match these, and then they can actually taste the mathematics, again, contextualizing our mathematics. But I want you to know that this is the way I think about it. Have a minute, and I just really need you to know I do think about it this way. So who can unmute and talk to me about Kelly's thinking? What teacher, who can unmute and say, all right, you walked by my desk, you saw that I did this. Who can talk to me about this? I'm going to call on some of my KCM friends, or I'm going to call on my teacher friends. You guys know me, you know.
You looked at making drinks that had the same amount of orange and different amounts of soda. So the one that would have less soda would be more orangey. I
love that, Cindy. That's exactly right. So what's interesting about this is that the first one, right, this one that I have, actually has 1 more dose of soda than the others. And so I had to think about it. What's interesting about a proportion like this, and you know what I know because we've taught middle school kids, is that then you ask them the question, they do this, and then you say, okay, so which one is orangiest? And they're like, I don't know, right? Right? It's the one with the least amount of soda that makes it the orangiest. So again, that relational thinking for our students is important. So here we go again. True story. This is my great-grandmother's recipe. If you can see me in your thing, I want you to know that this is my grandmother's recipe book. And when I open it, it is my great-grandmother's recipe book. It is my great-grandmother's handwriting. And this is a recipe that she has for butterscotch brownies. So I typed it over there on the side. It is a treasure that I have, and those of you that know me know that the recipes that my family has handed down to me are some of the treasures that I have. But guess what? In my house, May says, I used to call her May. You didn't call her grandmother or great-grandmother or granny. You called her May. And so May says that I'm supposed to have an 8x8 flour pan, but guess what? This is all I got. All right, this is it. I'm trapped in quarantine land. This is all I got. So I have, it's a 9x13. So my question to you is, what do I have to do? I'm going to bake these brownies. What am I going to do in terms of scaling the recipe. So I'm looking again in the chat. What's your suggestion for me? What am I going to do with that? Yes, Lisa says, what a treasure that I have that. Indeed, when you talk about something that mad. Oh, like Julie says, she's hungry. I really want you to think about that. What do you want me to do with the recipe?
So Julie asks if you want thick or thin brownies.
Ah.
Ideas she's playing with.
How about if I say to you that if you're going to do this with Tristan at home, Julie, have that conversation, but it's okay to me, whichever one you want to tell me. Because I think there's a couple right answers here. I think there's a couple, I think there may be infinite right answers, but I'm thinking there's a couple right answers. I see some of my baking friends out there. Ah, there's my friend Darren. Darren, I promise you when I'm driving to work, I'm coming to see you. Darren says, hey, look, here's the volume of your pan. It's about twice, so I think you should double your recipe. Beautiful. Haley Hall. Oh, you talk about a cook now. My friend Haley Hall can make some awesome food. So indeed, Haley, I think I would do that. Ah, Lisa says, you know what? Go ahead and make your regular recipe, but decrease the baking time. Ooh, you're right. So no scale, right? No scale. Beautiful. Beautiful, beautiful. So indeed, I'm thinking double it depending upon what the brownies is. There's some logic behind maybe that half more of the recipe. Yeah, there we go. Sandy Lane says, I'm thinking that maybe it's about 1.8 times larger. So we could think about it that way. But you know what? Now is the time for kids to be able to think about recipes, think about how much they make, and be able to double and triple. Imagine how rich of a contextual question kids can have if they double their shortening, they double the flour, they double the salt. Thinking about teaspoons versus cups and finally being able to use such things as measuring spoons, right? And cups and being able to cook. Haley, I hope you're cooking with the kids because I know that as a good cook, that's one of the things that they'll remember during quarantine time. So beautiful. You're right. Julie says this is a skill that we miss. So the next part that I'm going to show you is just a technology integration, and I'm being mindful of the time. I'm going to escape out of here. I'm going to stop sharing my screen. Oh, I lied about that. I'm going to continue sharing my screen. I'm just going to escape out of the presentation. And I want to take you to the PhET interactive simulations. Now, I knew about PhET when I was a math and science teacher, and so these have been around for a while. They have the coolest little proportional reasoning, actually beginning proportional reasoning simulation. So the first thing, again, contextualizing our proportions, we're thinking about, all right, so if it's about $2 for 5 apples, I wonder if I could compare. So notice as I'm going to click here, a new box comes on. I wonder what if the other one happened to be that it was $4.99 for a bag of apples, but there happened to be 15 apples in there. So I wonder what is the better buy. So I can click this button right here, which is cost per apple, and it actually shows me the cost per apple for the kids. So take a look and notice, I can take that off and I can put that back on. Very simple. You can see right here where it's actually showing me along a continuum about how they are related. You can actually see that the triangular piece is kind of lower than the other one. And so I just thought that that was a really great way to show proportions. Going to show you another thing. This happens to be called Math Splat. This is the materials that I've linked into your handout. Again, same idea. What if I did 3 blue and 2 green? I'm sorry, 2 yellow. That makes that kind of green. Notice how I click that button at the bottom. I wonder if I did 5 blue, I wonder how many yellows I would need. So I can visually see I have more paint, physically more paint. I can see that the hues are different, and then notice again where my slider happens to be. So kids can think about this, right? They can think about this and try to get it to be the same color. And notice as I increased in the blue and decreased, all of a sudden a 3 to 2 gives me the same hue as a 6 to 4. So again, a great, happens to be a really good simulation, and something that I really enjoyed using with the students. So I'm going to go back to my presentation and just kind of tell you that those are, that's the technology integration that I think that your students will enjoy. The link to the FET Colorado EDU simulation is called Proportional Playground, but there is so much more at that very same site. So today on my agenda, I wanted us to talk a little bit about research. I gave you an article that I know that you're going to love to be able to read by Dela Cruz, and it had the Better Buy information on it. Darren, I want you to, when I see you after they lift the quarantine and we talk about this, I hope that you tell me that you sent that out to your kids, and however it is that you're doing your Google Classroom. So what was the best buy? Again, fizzy orange juice, right? Cheers to you guys. So the fizzy orange juice, you may even want to try that with your own students, and family recipes. Contextualizing the mathematics was really important. Proportions are a very integral part of that. Thinking about FET simulations. One of the things that I want you to know is that the Kentucky Center for Mathematics, our sheer goal, number one, the reason why we exist is to support the teachers out there working hard and to provide high quality professional learning. I have had this mantra for a really long time, better together, and I've now brought it here to Kentucky Team KCM. And so those of you that are my friends there across from a variety of places know that we are indeed better together. The math that I want to leave you with is this idea that proportions have multiple entry points. Please, please keep cross multiply and divide out for later. Allow kids to build up, do reduction, factor change, common denominator, and unit rate. And then of course, these are series. And so there is a series of professional learning that we do here at KCM, 30 minutes, it's fast, it's furious. Tomorrow is more proportional reasoning with Cindy Aussie. She started us on Monday, she's ending us tomorrow. I always love what she presents. Kentucky Mathematics is a vibrant website. We hope that you'll bookmark us and our virtual site. Everything that we do is housed here. And of course, I'm Kelly DeLong. I'm the Executive Director for the Kentucky Center for Mathematics. This has been fantastic. I loved that a lot of my friends are out there, and that makes me smile. But better yet, I hope that this afternoon, you'll be thinking about what you're going to be doing with your students. And I have encouraged you to slow down, to give them some rich tasks, allow the students to think about it in the real world aspect. Now's the time. I thank you.
And then at this point, Kelly's been asking everyone if they'd like to unmute or put into the chat box some feedback and to give some applause for the person who's been presenting. And so now I'm going to ask that for you all to give Kelly some thank yous for this really good session today.
I love it that my Bobby Fryman says slow down and that less is more. Exactly, exactly. That's our message. Now's the time. Kids can go really good and deep. I thank you for your kind words. This is the kind of stuff that we love to do at KCM. All right. Thank you guys. Appreciate you.